Hello and welcome to this Elektor webinar, MCU Viewer Visual Debugging for Embedded Systems. I'm Tristam Williams, and today we're diving into a powerful tool for embedded debugging called MCU Viewer. In the March-April edition of Elektor, Piotr Wasilewski, an embedded systems engineer from Poland, brought us this article called MCU ICU. And it was a great in-depth article, and we wanted to know more about it. So today, Piotr is joining us to teach us more about it. Piotr, how are you doing today?
Doing great, thank you.
Excellent. I'm looking forward to this session. It was a very interesting article. But before I get started, I want to take the time to tell you about our sponsor today, Vurt Electronic ISOS. Vurt Electronic ISOS Group is a manufacturer of electronic and electromechanical components for the electronics industry and a technology company that spearheads pioneering electronic solutions. Vurt Electronic ISOS is one of the largest European manufacturers of passive components and is active in 50 countries. Production sites in Europe, Asia, and North America supply a growing number of customers worldwide. And before we hand over to Piotr, one more thing, we do, of course, have a giveaway. So this is what we have. We have 3 copies of this to give away today. It's called Programming with STM32 Nucleo Boards. This hands-on book covers everything from blinking LEDs to using expansion boards with sensors, motors, Wi-Fi, and more, all on STM32 Nucleo hardware. So whether you're new to ARM microcontrollers or building complex projects, this guide is a solid resource. So stick with us for that. The competition page is ready to go, but we'll give you the code word a little bit later to fill in here, as we always do. Okay, so let's take that down and we can get back to Piotr, who will take us through how MCU Viewer works and show us some live demos. Over to you, Piotr.
So hello everyone, my name is Piotr Wasilewski, and today I want to show you something more about MCU Viewer. So my part of the webinar will look the following. We'll see some slides about MCU Viewer so that we are aligned on what it is, how it works, and then we'll move to a real demo where we will measure some signals, profile some interrupts, and then we'll move to the Q&A session in the end.
Yeah, sorry, okay. I should interrupt you just to say there's a lot of people from around the world in the chat, and please do drop your questions. We will take them after the presentation.
Sure. Okay, so what really is MCU Viewer? MCU Viewer is a PC software tool for real-time display and analysis of microcontroller variables. So whenever you're working with a control system where you have some sensor inputs and some actuators or transistors, if it's a switch converter, then you usually want to visualize the signals to be able to analyze it, to see whether the transient behavior is correct. And with MCU Viewer, you can display these signals in a very quick manner. So you can easily set up the project and see the signals, how they behave in time. But not only that, you can also manually control the program flow in real time. So if you're tuning the control system or changing the behavior of a state machine, it is very quick to do with MCU Viewer because you don't have to prepare all the communication protocols. You can just change the values of variables in your code directly. You can easily debug glitches or noise in your system. So for example, when you're measuring some signals with ADC, you can see if the channels aren't coupled in some way, which can happen sometimes. And the biggest advantage, in my opinion, is that you need no additional devices apart from the debug probe that is connected to your target anyway. So when you're programming, usually the only device that is connected is a debug probe. So you can easily use that to connect to MCU Viewer. And MCU Viewer has 2 main modules. So the first one is called Variable Viewer, and this is a sampling module that samples the addresses of your MCU in regular intervals. So basically, you load the ELF file into the MCU Viewer. It then parses the file and gives you a list of variables from your software. You select variables that you want to visualize, and then MCU Viewer, using the debug probe, reads the values of memory under these addresses, and then interprets them back and displays them in form of these plots. So this module is very good for medium frequency signals because it has limitation on the maximum sampling frequency, which is dependent on your debug probe, but also the SWD speed that can be achieved between your target and the debug probe. So there might be some problems when you're working with mains power devices or high voltages where you need an isolator here. So the SWD speed is limited. But for these cases, you have a recorder submodule that was implemented in the newest revision of MCU Viewer, which allows you to visualize even very high frequency signals with limited SWD speed. We'll see recorder module in action in the hands-on demo later on. And the second module is called Trace Viewer, and this module works quite differently because it visualizes the SWO trace data that is sent by your target. So you compile in special markers in your code that depict the transition from low to high state on a plot and high to low state also on the plot. So you can use it for profiling, like with a simple GPIO pin and the way that you turn it on when you enter the interrupt and turn it off when you exit the interrupt, so that you can measure the time period it took to execute the interrupt. But you only use one pin, and the SWO pin allows you to visualize up to 10 channels in case of MCU viewers, the MCU viewer. So it is so it can be easily used to display multiple channels in parallel or visualize multiple interrupts. But not only that, it can also visualize high frequency signals. So not only binary signals, but signals like float variables or Uint32 variables, and we'll see that also in the demo. The disadvantage of this module is that it's not available, the trace peripheral is not available in the Cortex M0, M0 Plus, and M23 cores because it is reserved for the higher end cores. Okay, so now we can move to the hands-on demo. So just a small disclaimer, this version of MCU Viewer that you see here is a pre-release version. So we're not going to see all the features, especially the recorder module in the version that is uploaded on GitHub. But this version should be also released quite soon. Okay, so on the left side, I have my project that is in Cube IDE. And I have a simple test class that generates some signals that we can measure here in MCU Viewer. The application also has some interrupts. So we have a 1 kilohertz interrupt, 10 kilohertz interrupt, 50 kilohertz interrupt, and 100 kilohertz interrupt. So from low to high frequency interrupts that we'll measure later on. But now let's come back to MCU Viewer. So the first thing you want to do is you want to save the project. I'll save it as webinar. Okay, and then you want to go to Options and Acquisition to select your ELF file. I'll pick the ELF file from this project that is shown on the left. Okay, and now we're going to go through the settings real quick. So we have some checkboxes here. The first one is to save the ELF file path as relative. So in case you want to share the project with someone using a repo, then, and you're going to keep the config there, then you want to select this checkbox to keep the ELF file path as relative, so it will work on other setups. We would like to also refresh the variables addresses whenever the ELF file changes. So basically, whenever you recompile your project, MCU Viewer is going to automatically refresh the addresses to keep them up to date with what's happening on the target. And we would like to also stop whenever the ELF file changes. so that you can download your code without the interruption of MCUViewer. For the sampling, we can go a little bit higher here. So let's go for 1 kilohertz. Okay, now maximum amount of points. This is the amount of points in the circular buffer that is used for the samples. So whenever you go above 10,000, the oldest points are going to be lost. And here is the amount of points visible on the screen. So if the interface gets a little bit laggy, ideally you want to dial it down a little bit. Okay, now I have a J-Link probe connected to my computer. So you can see I have one probe connected to the PC. Here we can go for 10 megahertz as the SWD speed, but as I said previously, this is a parameter that might be different on different setups. So keep that in mind, that in some cases you might want to get more conservative here. Okay, my target name, I'll pick a generic device, so Cortex M4. And here we can pick either normal or HSS mode, which stands for high-speed sampling. This is a proprietary mode from Zegger, and it allows you to reach very high speeds, even in variable viewer. So you can reach up to 50 kilohertz of update rate, of sampling rate, using when you sample 1 or 2 variables. So it's very fast. And we'll leave the rest of the settings for now. Now, when we click Done, you can see that these 2 buttons are no longer disabled, so we can import some variables from our project. And I'll pick some of the more interesting ones. Okay. And as you can see, they are here in our project. The whole MCUViewer is zoomed in, so keep in mind that when you download it, it won't be that little space for every widget that you see. So this is only for the webinar purposes. Okay, and now we can basically just drag and drop some signals on the plot. And when we click Start, we can already see them being sampled. When we zoom in, we can see some traces, but this is only the reading of variables. We can also write them. So let's now create a new plot called control. Let's call it like this, and of type table. And you can see that an empty table was created on top. So now we can move some variables that we want to write here, and we can change the amplitude on the fly. So this requires no logic on the target side. It's just changing the variable on the go. So let's now display a faster signal. And we'll also change its frequency. So currently we have 50 hertz. Let's start from 10. And as you can see, when the signal is quite low frequency, we can easily visualize it, and it's not too much distorted, I'd say. But when we speed it up to say 500 hertz, the aliasing is pretty much destroying our signal, so it's not usable anymore. And in this case, you have 2 ways of handling this situation. You can either try to go higher with the sampling rate, or you can enable the recorder module. So the recorder module is more invasive than the normal approach, because you have to compile in some sources to your project. So here's a recorder C and recorder H files, and we have a recorder defines file here. So here you set up some parameters of your project, basically the timestamp, so the period with which you call a special function that collects the data, the maximum amount of RAM that you want to give to MCUViewer for the samples, the maximum amount of variables that you're going to sample, and if you're supporting floats or not. The usage after you add the recorder to your project is only calling a single function called recorder step, and I'm doing that in 100 kilohertz interrupt. So now this recorder module is compiled into my code, and I can click detect recorder. As you can see, it was detected, and all the parameters are here. So when I click done, now I am able to create a new recorder group. Let's call it recorder. And we'll drag and drop the triangle signal from our sampling group. And now you can see that the signal looks perfect. We have all the samples here. We can easily analyze it. And let's turn on the cursors to check if the frequency is the same as we wrote. Okay, so it's around 500 Hertz, just like we set it in the control plot. And let's create a new control plot here as well. And we can also put frequency here. So let's go a little bit lower because I want to show you how triggers work. Since the recorder works with high frequency signals, you have to be able to stop, like an oscilloscope, whenever you detect some level of signal that you're interested in. So this is why triggers are implemented. And here we select the triangle signal as the source of the trigger. So when I start, you can see that the signal is being stopped on each occurrence of the trigger condition. You can also use the single mode to catch one-time events and switch to normal mode, just like on an oscilloscope. Okay, so I think this is the main idea behind the variable viewer. So now we can move to the trace viewer module. And here also, first we want to go to the options and acquisition settings. We want to set up some parameters, so we'll leave these as defaults. Again, I'll choose J-Link. The ID is correct, the SWD speed is correct, and here I have to select my device, and it is STM32 G474CB. Okay, we can click done, and now we have to select the core frequency that we're running. So 150 kilohertz, 150 megahertz in my case. The trace prescaler, this is the prescaler of the trace peripheral. So depending on your probe, you want to go a little bit higher if the probe is not able to keep up with the signals, or a little bit lower if it's able to parse high frequency SWO output. So I tested it before, and I know that value 2 is working in my case. And basically we're ready to go. So when I click stopped button, you can see that it's running and collecting some data. And this data looks like on a logic analyzer, but it's generated with these special markers placed in the code. So we can see that we're accessing the ITM, internal trace macro cell peripheral, and we're writing some data into the selected channels. And this works the same way as it would with GPIO toggling. The difference is that it works with multiple channels in parallel. So as you can see, we're writing some values. In this case, 0xAA means transition from low to high state, and 0xBB means transition from high to low state. And MCUViewer parses this data and plots it in this form as on the right side. So basically here we are profiling the 1 kilohertz interrupt and all of the other. And to prove that it works like toggling a GPIO, you can see that I'm toggling the GPIO here and also using the channel 2 of the ITM peripheral. And here I have some dummy memcopy, which copies 128 bytes and a memory barrier that makes sure this part won't get optimized out. So now let's see channel 2. This is this channel. We can zoom in and place some cursors to see how much time it takes to copy these elements. So it's around 6 microseconds and 152 nanoseconds. And now I have a logic analyzer connected to my setup on the GPIO pin. And let's see how much it takes. 6.125 nanoseconds. So it's very, very close to what you would achieve with a normal GPIO approach to profiling. But this is not the only use case, because you can also display some, as I call them, analog signals. So we're using channel 4 for that. And we have a float variable test.triangle from the variable viewer demo. And basically we're type panning it to get the binary representation of the float and writing it to a uint32 union of the register. And here we can see that channel 4 is also enabled, but we have to switch it to analog. And now when we click start, you can see that the signal is here, the same signal that was sampled in variable viewer. So depending on whether you're working with a high-end core like Cortex M4, M7, and you have the trace peripheral, you can go for trace viewer to visualize even some analog signals. But you can also use the recorder module in case you're running very high frequency signals in your setup. And I think this is the last demo that I wanted to show you. I guess if you have any questions, I'm open to answering them. And thank you very much for your attention.
Well, thank you, Piotr. That's very impressive real-time performance. It's one thing reading about it, but seeing it in action here was very impressive. I see some people from Instagram are having trouble seeing the small screen. You can always catch this now or in replay on Elektor TV on YouTube. And we do have some questions. We've got people joining us from all around the world. As I said, Frank de Hert is a regular viewer from Belgium, and we've got Germany, Illinois, and we've got everyone from sunny Scotland to where I am, South Africa. So thanks for joining us, Raymond, from around the corner, I presume. And Deconti Engineering says it's a neat topic, which indeed it is. Now, I can see that this is C++. We've got a question about C++ here. You are using C++ in the demo. Is it compatible with any C programs?
Yes, of course. So the variables that you're looking at here are basically global variables from your setup, from your program. So whenever you add a global variable, whether it's C or C++, it doesn't matter. It will work and it will show up here on the list whenever you import your ELF file. So yes, it works with C also.
Great. And then I have two related questions about Mac OS and Linux here. How do you ensure cross-platform compatibility, particularly for Linux and Mac OS users who often lack access to polished embedded tools?
Yeah, so actually the newest MCU Viewer version that you're seeing here is also Mac OS and Linux compatible. I've managed to get some macOS and Linux setups that I test MCUViewer on. So hopefully within a month or so, you'll be able to also run MCUViewer on macOS, which wasn't available up until now. Yes, so that will happen hopefully very soon. And if you'd like to test the pre-release version, you can also give me some contact or write an email, and I'll try to set up a testing version.
Awesome. And thank you to Michael for sharing the link to your GitHub. So if you want to take a look at Piotr's work, you can check it out there. But obviously, there's a lot more to come. And question from eTech USA. In the Elektor magazine article about this, it says other features are coming, like XY plot and fixed point variable interpretation. Are you working with on that, or are community members working on?
Yes, so the XY plot is already implemented. As you can see here, we can add a new plot of type XY. And also the fixed point representation is also enabled. So you can open the variable edit window, and here you can select a representation or the interpretation of your variable. So you can select the fractional bits and also the base. It can be either a variable that is on the sample list of MCUViewer, or you can type in a number for the base. You can also shift the number before the interpretation and mask it. This is usually useful when you want to extract certain bits from your variable. So that might be useful. So to answer your question, yes, these features are already implemented in the new version.
Well, that's awesome. And going back 25 years ago, I had a 486 PC, and I had no logic analyzer and no oscilloscope, but I wanted to monitor fast signals. So what I had to do was sample from the parallel ports, use that as a logic analyzer, but disk speed was too slow, so I had to sample using assembly code directly into RAM, and then when the RAM was full, write that out to disk and manually then analyze the data. So this is very impressive considering where I come from.
A lot of work.
It was, but when you can't afford the proper tools, you make a plan. And I like the plan you've made in particular here. This is exciting stuff. Another question from eTech USA related to that. How does MCUViewer handle large volumes of real-time data without affecting the performance of the target microcontroller?
So it depends on the mode that you're working in. We have the two types of groups. So we have a sampling group that doesn't affect your target in any way because it only uses your debug probe to read the addresses. So it's just the same as you would attach a debugger to your running code, to your running target. But in case of the recorder module, then you have an overhead of running this function here. So I can, from my experience, I can say that this function takes around less than a microsecond per variable with triggers enabled on a Cortex M0 running at 80 megahertz. So I'd say it's not that critical, and when you have some runtime left in your application, then this is a great way to visualize high-frequency signals. So to answer your question, the sampling group doesn't affect your target, but the recorder group does. And in case of the trace viewer, the only runtime penalty is these register writes, which, in my opinion, aren't really an overhead. So, yeah.
Awesome. I see we have reached the bottom of the hour, so let me just get back to the giveaway. Give out the code word. If I can get my screen up there, please. There we go. Thank you. So we're giving away Programming with STM32 Nucleo boards, the ebook, and the code word for today, based on the article that Piotr submitted. It's MCU-ICU. That should be easy enough. And there's the link and the code word on screen now. I'll take my screen down. And back to you, Piotr. And question here, can you share your demo code? And I think, if I'm not mistaken, it would all be on your GitHub, right?
Yes, I think an older code is on the GitHub, but I will also share this code. That's not a problem. Sure.
Awesome. Question here, can we use GPI opens for trace viewer?
No, so it's actually not a logic analyzer. It only uses the SWO-pin. So it's a serial data that trace viewer interprets as these traces. So basically, no, you cannot use GPIO pins.
Okay. Another one for you is embedded ST-Link can it be used as a probe?
By embedded, I guess you mean that from Nucleo or Discovery boards, and the answer is yes, you can use them, but you have to keep in mind that ST-Link V2 is slower, so you would have to go more conservative on the SWD speed and here on the trace press color. But generally, yes, they should work fine.
Okay. And I guess this a non-technical question from me would be, what was the moment that you decided that you need to make your own tool? What was the reason you did it?
Yeah, so I was working in the previous company and we were building like robotics drives there, motor controllers. And I was fed up with the software that I had at that time, which was STM Studio from ST and Cube Monitor, because one of them, STM Studio, was already deprecated and had a lot of bugs, and it made the work really hard. And also the Cube Monitor, so the newest version of the year software, is more of a software for building dashboards. So it takes a lot of time to create a config. It is basically very lengthy setup process for you to display simple variables values, and then the plot manipulation. So it was very hard to, like in MCUViewer, zoom in, zoom out. I think you couldn't even place cursors on the trace. So in my opinion, it was just useless in the application that I was going for. So high-speed variables readout. And then I decided to create my own tool. So first it started as a very small module, but then I saw the potential that it could be used by a wider audience and started developing it also in my free time.
Okay, so you had more than enough reason.
Yes.
Ahmed
that's right.
wants to know if the software will focus on other ARM variants in the future.
It depends what you mean by other ARM variants. I guess the A series, maybe. So actually, I have tested MCUViewer only on Cortex-M. So this is something that maybe you can even do, because right now I cannot say it works with other ARM versions other from Cortex-M.
Awesome. And then Andy Leach says, thank you for taking the questions and for sharing. And I have a question from Andy. Sorry, I'll get back to you, Adalbert, but from Andy, it is implemented in 10 microsecond interrupt. Does the interrupt latency affect the accuracy of your timing measurements?
So by interrupt latency, you mean the, for example, when you have two interrupts that can preempt each other, probably, and this is what you mean. So basically, ideally, you want to put the recorder step function in the highest priority interrupt so that it doesn't get interrupted by other interrupts. So it doesn't get preempted by other interrupts. So if you place it in a lower priority interrupt, then yes, the accuracy will be affected.
Great, thanks. Now back to Adalbert or AD Albert. I think you covered this, but how does the system work, if you could clarify? Does it mean CPU time overhead?
So in case of the sampling group in the variable viewer, there's no overhead because you're reading the data from the debug probe. But if you're using the recorder, then there will be some overhead from calling this function. In the trace viewer module, you'll get some overhead, but in my opinion, it's very minimal because this is only the register writes that you can see here and here. So yes, generally it depends on the mode that you're working in.
Great. And another compliment for you from Robin Davis. I use it, great tool. So glad this came along after STM Studio was discontinued. Well, Piotr came to save the day. As an interesting question, can I use this tool with ESP32 boards or Raspberry Pi Pico 2W? I'm guessing no.
So it depends on which probe you're using. If you're using J-Link and it supports these MCUs, then this is just fine to use. Wow. But recently, someone started a topic on GitHub regarding the support from Raspberry Pi debug probe. And this is not yet working because you basically, to support a new probe, I need some SDK for this probe. So I need a module or a library, as you call it, for running the probe. So this takes time to implement, but there's no reason not to implement any other popular debug probes if they are supported by a library.
Well, that's impressive. I thought it was all ARM. Speaking of which, why is Cortex M0 not supported?
So Cortex M0 is supported, but only in the variable viewer module. So in Trace Viewer is working based on the trace peripheral, which is not in the core. This is the ARM's decision. So it's basically not implemented. The trace peripheral is not implemented in Cortex M0, M0 Plus, and M23 cores because they are a low-cost solution. So I guess this is why they decided not to implement it. But again, you can still use the variable viewer, so the sampling groups and the recorder groups, and this works just fine. I'm working with Cortex M0 Plus like every day, so I can assure you that it works like it should.
Great, good question. And please keep the questions coming. I have one for you. What kind of projects do you find have benefited the most from MCU Viewer?
So I think the motor control ones and switch converter projects. So the ones that require high control loop frequency and where these signals have to be like visualized at high rate, I'd say. So yeah, whenever you have to deal with a control system that works at high frequency, I think a tool like MCUViewer is indispensable, whether it's just setting up the gains or seeing the signal. You cannot really fully see the system without it.
So motor control is a key application for you. And in terms of the community, you've got that GitHub page. Have you found any unusual or unexpected ways people in the community are using it?
I don't think so. I mean, I'm happy to hear about any unusual projects that people use MCUViewer in, but up until now, I haven't seen any like exceptional uses of MCUViewer. Yeah.
Well, it's already exceptional software, so good enough for me. Question here is STM32H7 family supported?
So it also depends on the probe that you're using. If it's S-Link, then I would have to check because I'm not sure if H7 is not the new family that has come lately. But if JLink supports it, then you can say it's supported. So basically, the answer is that it depends on the debug probe that you're using.
So both ST-Link and J-Link, was that a challenge to be hardware agnostic and support them both out of the box?
Yes, actually, it's quite hard in the ST-Link part because I'm using another project from GitHub. Since it's a open source project, there are some issues with supporting newer devices. So there's always a problem with this. But when we talk about JLink, I managed to contact Zegger and get a full support from them. So big thanks to JLink to Zegger for supporting MCUViewer. And I think JLink also allows you to monitor different families. So this is the biggest advantage of implementing JLink probes. And I think it might be also the case with Raspberry Pi probe, if it ever comes.
Great. And did you reach out to Zegger early on or later in the development?
So I think it was around a year ago or so. They contacted me through LinkedIn, and step by step we managed to set up the JLink support in MCU Viewer.
Okay, and before I ask my next question, let's get the question from Vinay on how to integrate this with RTOS.
So you don't have to integrate it per se. You can just display the variables from RTOS if they are global, of course, because the addresses have to be constant throughout the whole program's lifetime. So this is the thing that you have to keep in mind. But if we're talking about the recorder module, then you'd have to make sure that this function is not disrupted by any other tasks. So I guess you would have to put it in some type of a critical section to work properly. And ideally, you'd like to put it in the fastest possible task or interrupt, so that you get a high sampling rate. Because basically, calling this function, how often you call this function determines your sampling rate that you see here in MCU Viewer. So the integration should be pretty simple.
Awesome. Another question from, I'm not sure how to pronounce it, some Ladenbrook. Multi-core processor support. Any opinions on that?
So I cannot say that I've checked the multi-core support, but maybe someone from the community already used that. I'm not sure. So here, actually, I cannot answer.
Okay, well, good questions nonetheless. I'm not sure if you can address this one. Is it a pure software solution with binary code overhead?
I'm not sure if I get the question. Is it pure software solution with binary code overhead?
I guess what I would ask is, does it take much resources on the target microcontroller?
Okay, so again, it depends on the mode. So if you're in the sampling group, then you have no overhead. But if you're working with the recorder, then you have to call the recorder step function, which takes some time, depending on the frequency that you're running at and your core and the optimization level of your compiler. So there are some factors that you have to remember about. But basically, the sampling group has no influence on your runtime. Trace viewer has minimal influence because you get only these register writes that I would compare to toggling a GPIO, and the recorder is the most amount of runtime that is burned for the recorder step function. So I hope this answers the question.
Yeah, it does for me. And finally, Alain says, thanks for the interesting presentation.
Thank you.
Yes, indeed, very interesting presentation. We've looked at what's already here, and what about the future? What do you think your vision for MCU Viewer, where will go, say, 1-2 years down the road?
So ideally, I would like to transform MCU Viewer into a product. I would like to make a enterprise version from companies and also a free version for hobbyists and basically people like me who like to tinker with demo boards and projects after work in their free time. I think this would be a great way to bring a even higher quality to MC Viewer because it takes time and money to support all these platforms and all the debug probes. So I think this is the best way to make MC Viewer even better and basically bring higher quality to the product.
And in terms of community contributions, what would be the best way if somebody wanted to help you out?
I guess testing is the best way to help out because I'm not able to keep all the targets and all the debug probes here in my lab. So when someone has some exotic microcontroller that he or she wants to test, then it is a great way to help. Also, the macOS users with Intel and ARM cores are welcome to help. To test the new version of MC Viewer. So I guess this is the best way to help.
Great. So testers, coders, docs, feature ideas, you need testers mostly. How is it with the documentation? Are you managing there?
So the current documentation is only in the README file, but I'm also working on preparing a GitHub IO page for the documentation that would contain step-by-step project configuration and data acquisition tutorial. So it is on its way to being public. Yeah.
So in terms of Christian's question, any training that can be found? Yes, on the GitHub page, which Michael was kind enough to share with us earlier. That's the GitHub repo.
There's a short README file, but if you have any problems, you can always contact me. You can visit mcuviewer.com to sign up for the newsletter. I'm going to send you an email when MC Viewer is released, especially this new version, and some info about the updates. So feel free to contact me directly.
Awesome. Another compliment for you. You're just running out of compliments today. Thanks, Piotr. Tool looks amazing. Can't wait to give it a spin. And I have a question from Jens here about ESP32 and J-Link. He's found that the RISC-V cores are supported C2, C3, C6, and H2. Well, that's great that you looked into that, Jens. Any comment there, Piotr?
Yeah, I would be interested in knowing if it works correctly with RISC-V cores. So I haven't tested it out myself, but since J-Link works with them, I guess it should work. Yeah.
Great. Thanks for that question. Well, Piotr, we are 15 minutes in and still getting some comments. Very interesting. Thank you.
Thank you.
A lot of compliments for you. So I want to thank you for joining us today, and especially for this live demonstration, which I've looked at your magazine article, but I must say seeing it live was very impressive. And also in terms of the question about documentation, besides your README file and MCUViewer.com, which I'm looking at now myself, don't forget that there's an article in the March-April Elektor edition called MCU ICU, which also goes very in depth. Oh, there we go. Thank you, Asma, for giving us the article URL there. It's quite long, but you can pause here if you want to visit the article, or you can just visit elektormagazine.com and search MCU Viewer. From Daniel, thank you very much for presenting this interesting tool, and from Dom, thank you, and from Jens, great webinar. Thank you. Well, thanks for joining us, guys. It's always great to have people from all around the world joining us. And let's take down your presentations. So we're done there, and bring us up like that. And I just want to say thank you for joining us, Piotr, and I look forward to seeing your future development on the product.
Thank you very much. Thanks for having me. It was a very nice experience.
Yeah, and for me too. I will certainly want to learn more about this. I will say thank you to everyone for joining us from around the world, and good luck if you're entering our competition. Remember the code word MCU-ICU. I also want to once again thank our sponsor for helping to pay for this today, Elektor ISOS. More than you expect. So thank you to everyone. Thank you, Piotr, and good night.
Thank you.